What is the greatest possible number of points of intersection for 17 distinct lines in a plane? Well, if you try to draw 17 lines, I could just start drawing, well, I could start drawing lines and then trying to count intersections. You will have a tough time. It's really hard to do it that way. The easiest way to do this problem is to look for a pattern. Okay, so if we have one line, there's no intersections. We need at least two lines to make one intersection. So let's keep a little table over here. So if we keep track of the number of lines and the number of intersections. Okay, we'll make this into a little table. So if we have two lines, we have one intersection. Okay, let's add a third line, and we want the maximum possible number of points of intersection. So I want it to intersect both lines, right? So let's just draw another one here so it intersects two lines. So what we've added is two more intersections because we've crossed the two existing lines, okay? So if we have three lines, we have three intersections. Or we could think of it as we had the original intersection and we added two more because we crossed the two existing lines, okay? Now if we add another line and we make it intersect all of the existing lines, okay, so this is the fourth line, we're going to have the first intersection plus the two that we added with the third line, and in order to get the maximum number of intersections we have to intersect all of the three lines that came before the fourth line, okay? So you see a pattern here, right? There's 1, 1 plus 2, 1 plus 2 plus 3. These are actually called triangular numbers. And they're called that because, they're essentially, there's 1. You could draw a triangle around that, I guess. Add 2 more, it makes a triangle, right? Add 3 more, and again, it makes a triangle. So it makes it, like a pyramid of points. So the Greeks actually name these triangular numbers. So let's see what would when we add the 17th line, we're going to cross all the 16 previous lines. So the total number of intersections is going to be 1 plus 2 plus 3 plus, and so on, all the way up to 16. Okay? So we need to add the numbers 1 through 16 in order to get our answer. Now you could add those one by one, or you could use the handy dandy little trick that I present in one of my lessons on counting lists of numbers. Actually, this is an arithmetic sequence, so it's adding an arithmetic sequence. Okay, so the fancy way to add this, the easy way to add this, is to take the number of numbers. So there's let's see. There's 16 numbers times the first number plus the last number. Okay, so 1 plus 17, or 1 plus 16 is 17, and divided by 2. So it's essentially 17 times 8. Oops. Don't know why I put a line there. 17 times 8. So what's 17 times 8? Well, let's see. We got 56, carry the 5, 136. So that's our answer, is that we'll have 136 intersections if we were to draw 17 lines so that they all intersect each other, okay, and get the maximum number of intersections, okay. So, just a brief summary of where this formula comes from. So it's the first plus the last number times the number of numbers divided by 2. That's the formula that gives us this. And the reason we the way we get that is if you were to write this sequence backwards, it would still add to the same thing. So you had 16 plus 15 plus 14 plus all the way up to 1. Okay, so we've just written the same sum. Let's call this S. This is also going to be equal to S, same sum. But you notice that these corresponding terms all add up to 17, 17, 17. So all we're really doing is adding a bunch of 17s. And how many 17s do we have? It's just equal to the number of numbers. In this case, it's 16. So we end up with 16 17s. But that's equal to 2s. Okay, that's twice the sum we want. So that's why we end up dividing it by 2. Okay? All right. So the answer is 136 intersections.